EDGECAM's finished grooving cycle provides excellent tool control. I'm excited to share some practical usage suggestions in this tech tip. Grooves are a common feature in many turn components. Here we see the machining simulation of a shaft. There's been turning work done to put in centering holes as well as turn the chuck end, and then we see heavy roughing being done once the tailstock is engaged in the centering hole. At the conclusion of heavy roughing, we'll bring in a finished turning tool to turn in the shaft, including some slight undercut areas where grooving technically isn't required with a grooving tool. And then we will bring in a grooving tool, and initially we see the efficient rough waveform turn cycle used to quickly remove the material. This machining technique is sometimes referred to as trochoidal grooving. It provides excellent chip control. Following the roughing, the same tool is going to be used for finish work, where the tool comes in, machines half the groove, and then comes in from the other side. We will take a closer look at this application later in the tech tip. Following this tool, a 3mm wide groove tool is brought in, which forms 3mm grooves with a simple plunge. This is something that's very easy to do with the finish groove cycle, and we're going to look at that first. Let's close the machining simulation, return to CAM. Then we'll turn off the visibility of the turning tool path so that we can focus in on the finished groove applications. I'm going to open the finished groove cycle that builds the tool path for the 5 3mm grooves. And I want to point out the option for tool width groove that is checked along with, to the left of it, pre-finished plunge. You need to turn on pre-finished plunge to get to tool width groove, and with that checked, it directs EDGECAM to target grooves that match the tool width. So in this case, if I turn off the visibility of the solid and look at what was targeted, we see 5 groove features. If I go to my features list and select one of those 5 groove features and look at properties, you'll notice that the groove width is the inch equivalent, because I'm in inch units, of a 3mm groove. And if I edit the tool and have a look at the tool width is an exact match. And so with the tool width groove option in the finished groove cycle, the tool plunges directly in and then lifts out. Let's look at the NC code and take a look at how simple the resulting NC code instructions are. We'll notice that the tool plunges into the groove, cut 1, cut 2, cut 3, cut 4, and cut 5. Simplest form of grooving, very, very easy to pull off in EDGECAM using the groove features and a tool that matches the groove width. If we look a little bit further up, we can see where the other finished grooving with the other tool is done, and notice that the tool offset is changing. We're switching between tool 5 offset 5 and tool 5 offset 35. And I want to focus now on how that's done. We can see in the finished groove cycle that the tool actually leads in, rolls a small break to force a small fillet, cuts half the groove, and then comes in from the other half. Let's look at both the tool and the finished groove instruction. Notice that on the tool, we have the tool position, but then we have offset and secondary offset for the 2 sides of the groove tool. And then in the finished groove cycle, pretty basic setup. We've got leads requested, as we can see here, some slightly different lead ins and outs. We have the corner break in a small radius at the top ends of the groove. And we see this option for change tool setting point. This allows EDGECAM to switch the tool datum from one side of the tool to the other side so that we can use our machine's tool offset control for precise groove control. That's all you have to do, but I do want to show what is done in the post-processor in case yours doesn't do that. So I'm going to head into the miscellaneous code constructor and select length offset, and notice that in here we're directing that the tool turret number and offset be output, and that causes the block to be output on its own line. Let's recap the key points of this tech tip. The Tool with Groove option permits EDGECAM to build toolpath to form grooves when the tool and groove width match. The Change Tool Setting Point option permits EDGECAM to build toolpath where the offset and NC code are automatically shifted to the back side of the cutter for the secondary portion of the groove. As a bonus, we have a brief addition to this tech tip where we roll back the curtain and show how the CAM work on this real-world application was simplified with some quick model prep. EDGECAM is part of Hexagon's production machining suite, handling the CNC machine programming segment of the manufacturing process effectively. Designer is also part of the suite, handling preparation for machining. This simple manufacturing assembly includes the work in process stock and finished part. When we turn off the visibility of the stock, we can see that the finished part includes splines, and those are done in a later manufacturing operation. Removing them from the turn part will simplify some of the turn work. We could still get feature recognition with them, but removing them from the model is easy to do and will speed up processing in CAM. So let's go do that. First, I want to copy the part. I never work on an original. So we'll make a copy using the copy command. And then when we go to paste, immediately to the right of that, instead of trying to snap to the model origin and missing a click, a little tip is to hit 0 on the keyboard and then hit the Enter key. 0 and Enter together will make sure that the copy is exactly in the same place as the original. Let's go ahead and rename the copy. And after renaming it, let's use Edit Properties to also change the color so that between both color and the name in the list, we can easily identify what part we're working on. Let's remove the splines from the shaft for the turning setup. You may be thinking that I'm going to use the Remove Faces command, and you're correct, but we're not going to use Remove and Heal for this example. That would work, and it would work just fine for getting the splines out of there, but I want to show you the Detach and Heal option and some of the things that this workflow brings. We'll knit the sheet bodies and we'll assign a unique color, and then I'll go select the faces to remove. Now, that selection also included some of the faces for the centering hole, but since we're in toggle select mode, we can easily grab those faces, remove them from the selection queue. And now the result is a whole bunch of items added to the structure tree. Let's take a look at the turn shaft first. Notice that in the turn shaft, the splines have been removed. This stage model will simplify our turning work, and we could have got the same with the Remove and Heal option. But let's look at what the Detach and Heal does. We see the model healed, but we also see these sheet bodies where the splines were removed. And these could be useful for other work, including perhaps building toolpath with simultaneous machining if necessary. So we'll remove everything, just leave one of those left, and we very quickly have built a stage model that will help our turning ops and potentially give us useful geometry for other work as well. We hope these quick CAD for CAM prep tips that we've shown will help your designer workflows and simplify your CAM processes. Do you have questions on this or other topics? Please contact us to discuss. We would love to hear from you.